Real-time data streaming in Databricks is a powerful capability which allows organizations to process and analyze data as it flows in efficiently and seamlessly. By leveraging Apache Spark structured streaming within Databricks, users can build robust, scalable, and fault-tolerant data pipelines to handle a continuous stream of data from various sources such as Azure Event Hubs, IoT devices, social media, logs, and more. In this new end-to-end video, I'm going to walk you through how we can architect real-time data stream using the VS Code Python generated data, Azure Event Hubs, and Databricks Notebook. We're going to see how we can use the multi-hub, which is popularly known as the Medallion Architecture, combined with Unity Catalog in Databricks for seamless real-time data streaming. So let's get started. Let's go ahead and create Event Hub and shared access signature to send and receive event from the source. So I'm going to come to the portal.azure.com. I can see I've got this Cornerstone Analytics Event Hub already created. So click on that, and then I'm going to come to under Entities, click on Event Hubs. Now, for now, I've got no event hub created. So I'm going to click on this plus sign to create a new event hub. And then I'm going to call this one weather streaming data. And then for the partition count, I'm just going to leave it at the default one, which is enough for this demonstration. So for the retention policy, this is going to be just for 1 hour retention time. And this can be up to 24 hours, that is a single day. So this is going to be a delete clean up policy. So all this is fine. So I'm going to click on review plus create, and this is going to be validated, and I'm going to click on create. So the event hub is now going to be created in just a matter of few seconds. So you can see we have the weather streaming data created. Now I'm going to click on that, and I'm going to go to the shared access policies. So I'm going to create a new policy. So I'm going to call this one weather SAS key, and then I'm going to click on manage. Now the manage allows you to send and listen to events. So I'm going to click on create. So this is now created. Now I'm going to click on that, and then we can see we've got the primary key, secondary key, the primary connection string, and the secondary connection string. Now I'm going to need the combination of the primary connection string and the weather streaming data, that is the event's name, in order to authenticate and be able to send and listen to events. Now this is sorted. I'm going to come to my VS Code in order to generate sample data. So I'm going to stick with this Azure Event Hub folder, which is on my local laptop, and I'm going to create a file. So I'm going to call this one weather underscore data.py. Now this is going to be a Python code that I'm going to be using in here. Now, I'm going to paste the code. Now, before I do the pasting of the code, I'm going to just quickly come here, and this is my GitHub. So I've got this real-time streaming data in Azure Databricks Notebook repository. So I'm going to put the link of this repo in order for you to probably play with the sample dataset and the Python, that is the notebook code. So I'm going to go to this weather data Python code generator in VS Code. And of course, I can see all the code in it. So I'm going to click on copy raw file. As soon as I click on that, I can come back to the VS Code editor. So within this weather underscore data.py file, I'm going to paste the code. So Control V to paste. It's really important first you install the pip install of the Azure Event Hub, so which is already done. I'm going to put a link of video on how to pip install the Azure Event Hub in the VS Code editor. So after you pip install the Azure Event Hub, now it's really important you import the necessary libraries. So we've got all the libraries, and then we're going to also provide the Event Hub connection string and Event Hub name. So we've got this connection string, which is equal to the primary connection string that we're going to fetch in a moment, and then we also have the event hub name, which is going to be the weather streaming data, and then we're going to create a producer client to send message to the event hub in Azure. So we have this producer variable equals to event hub producer client dot from connection string, and inside this open and close bracket we have this con underscore str equal to whatever value is that we pass into this connection string, and then for the event hub name, this is going to equal to whatever is the name of the event as we define in this variable. And then we have this list of city. So let me just move this down a little bit so that we can see what's going on. So we want to generate some random data. So we're going to have this city such as New York, Los Angeles, Chicago, Houston, and so on and so forth. And I'm going to generate the latitude and the longitude. And then at the bottom, we're going to generate, randomly pick the cities, including the latitude and the longitude. And then we're going to return inside this dictionary. We have the city, latitude, longitude, temperature, humidity, wind speed, pressure, precipitation, cloud cover, weather condition. Now, these are similar to columns in a tabular format. And then at the bottom here, we're going to create a batch of events. So we have this variable which is equal to producer.create underscore batch, and then we're going to also generate a sample weather data. So it's going to be a variable weather underscore data, and it's going to be looking at the generate underscore weather underscore data, and then we're going to store the data as a JSON. So we can see we have the JSON.doms, and it's going to be feeding into this intermediate variable name, and then we're going to add the JSON formatted data to the batch. So we have this event underscore data underscore batch dot add method, and then we have this event data that we imported equal to the messages, and then we're going to send, and this is going to be going on every 5 seconds. Now, this cannot run except we provide the connection string and the event name. So let's quickly come to the Azure portal, and I'm going to fetch the connection string. So I can copy the primary connection string, copy into the clipboard, come back to the VS Code editor, and I'm going to select this placeholder value, and I'm going to paste that string in there. And then for the name of our event, that is the weather streaming data, I'm going to just copy this and Control C, and I'm going to come carefully into this placeholder. So this is going to be our event hub name. So select this placeholder value, and I'm going to press Control V to paste. So that's all we need to do. Now I can click on this play button, and let's see what happened in the terminal window at the bottom. So we can see we have data being sent. So this is the very first data that is being sent to our event hub in Azure platform, which is absolutely cool. Now this is sorted. Now I'm going to come back to the portal, and I want to check the data. I'm going to come to the overview. In the overview, I'm going to scroll down, and you can see we have evidence of live data coming into this event hub, which is absolutely fantastic. Next, we want to create the Databricks cluster and install the Maven library that allows us to connect to the Azure Event Hub and begin to stream the data into the Databricks platform. So I'm going to come here, and then I'm going to go to the compute, and then I'm going to create a new compute, and I'm going to call this one weather streaming compute. You can use whatever name you like as the cluster name. So compute, and once I'm done with the name, press enter to commit. And then for the policy, I'm going to choose a single node. And then for the performance, now I'm going to come here, and I'm going to point to the 12.2 LTS, which is what is available to access the Azure Event Hub for now. So we have this runtime 12.2, and the Scala is 2.12, and the Spark is 3.3.2. So I'm going to just leave this full font acceleration there. And then for the node tab, I'm going to just leave this standard D4DS underscore V5, and then this is going to terminate, let's say, every 30 minutes in order to save some money. Now, it's really recommended that if your computer is not being used, please always terminate it in order not to incur unnecessary costs. So having done all of this, we can see the summary. So we can see we have just a single driver, and the runtime is going to be this 12.2, and then we have the Unity catalog enabled, which is really important. Now I'm going to click on create compute, and then this is going to start spinning. I'm going to come to the libraries. As that is going on, I want to install the Maven library. So I'm going to click on install new, and then I want to pick the Maven library space, and then we need to provide the coordinate that allows us to establish connection to the Azure Event Hub. So if you know the coordinate, you can just copy paste directly, but you can always set for the packages. So I'm going to click here, and then I want to set for Azure Event Ops, and then dash Spark. So we're going to say this list has been narrowed down. So we can say we have the Azure Event Ops Spark parent, and then we have this Azure Event Ops Spark underscore 2.12. So I'm going to pick this latest. So click on select, and then we have the coordinate already provisioned or just produced here. Now I'm just going to click on install, and I'm going to wait for that library to be installed, and then I'm going to wait for the weather streaming compute to be ready to proceed. All right, so the weather streaming compute is up and running, and then we have the library installed from Maven. So this simply means that we've established connection to our Azure Event Hub, and we can start our streaming data. By the way, if you're yet to subscribe to the channel, please click on the subscribe button and toggle on the bell icon to be informed of new videos. Thank you. So let's go ahead and import our notebook from the GitHub. So I'm going to come here, and then I want to go to this Databricks real-time streaming, and then you can see the notebook in here, and I'm just going to click on raw, and then I want to copy the URL for the row. So Control C, and I can return back here. So I'm going to go to Workspace, and then I want to go to Workspaces, and then I want to go to User, and I'm going to select my Enter ID, and then I'm going to click on this kebab, and then I can see the import functionality. I can see the URL. So I'm going to paste the URL and then click on Imports. All right, so we have this Databricks real-time streaming data notebook, and I'm going to use the Python language for our data processing. So I'm going to follow the multi-op, that is the Medallion architecture that consists of the bronze, silver, and the gold layers. So we're going to start by using the read stream to read the data from the event hub, and then we're going to write into this bronze layer, which is going to be the raw data, and then we're going to move the data from the bronze layer into the silver layer, and then we're going to transform the data by cleaning the data, and then we're going to perform some aggregation, that's some calculation in the gold layer, and afterwards we're going to create a Power BI report using a direct query. So I'm going to just move that a little bit, and then I've got some notes at the bottom here so you can take your time and look at them. Now, it's really important we attach the cluster to the specific book, which I've already done, and then we're going to start off by importing some of the required libraries. So we've got all of these. So from PySpark.sql.functions, so we're going to import star, and then we're going to also import the call from JSON, struct type, struct field, string type, double type, and so on and so forth. So I'm just going to press Control Enter to run this code, and then this executed nicely. Now I'm going to scroll down. So we're going to set up the Azure Event Hub connection. So we can see we have the connection string, and we're going to pass in the primary connection string and then the Event Hub name. And I'm going to quickly fetch that. So I'm going to come back here, and then I want to go to the shared access policies, and I want to go to the weather SAS key, and I'm going to copy the primary connection string similar to what we use in the VS Code editor. So come back in here. So I'm going to select this placeholder value carefully, and I'm going to paste the string. And then for the event hub name, I'm going to just come back here, and I'm going to copy this weather streaming data. Come back here. I'm going to get rid of this placeholder value, and inside the double quote, I'm going to paste the event hub name. And then we have the connection string dictionary. Now in the dictionary, we have this event hubs.connection string, and we're going to be using the event hubs utils to encrypt the connection string. And then we're going to also pass in the event hub name, which is the same thing as what we have here. And similar to the connection string here, we just pass it inside this encrypt. And I'm going to go ahead and run this code. So press Ctrl Enter, and this executed nicely. So let's move to how we can create the Medallion architecture. We want to create catalog, schemas, and volumes. So first, we're going to define the storage location for our catalog. So we have this storage location, and then we're going to point to the storage location ABFSS path. So how do we get this? I'm going to come to this tab, and then I want to go to the catalog, and in the catalog, click on this settings, and I want to go to create external locations. So we have this URL. So I'm going to move this, expand a little bit, and this is our storage location. So I'm going to copy that, come back in here, get rid of this placeholder value inside this single quote, Control V, and oops, okay, let me just move this line properly, delete. Okay, so this is the storage location, and then we're going to create a Unity catalog named weather, and it's going to be a managed location. So we can see we have the storage underscore location passed inside this curly bracket in here, and it's going to be where the Unity catalog will be managed. And then we're going to create bronze layer schema. So this is named bronze, so this is going to be within the weather unit catalog. So we're going to create the silver and the gold layer within the same weather unit catalog, and then we're going to create the bronze layer for checkpoints. Now the checkpoint is going to be used for processing our data coming from the Azure Event Hub to ensure fault tolerance and data recovery in case of failures. So we're going to create the volume for each of the layers. So we have this create volume, which is within the weather catalog .bronze volume. So we can see we have the Spark SQL. So the same thing for the silver. So create volume weather.silver volume, and then we're going to also create volume weather.gold volume. So I'm going to just go ahead and run this code. So this should work nicely. Okay, so it's executed nicely. Now we can see that catalog in it. Now we're going to click on this refresh, and then we should see the weather catalog. So I'm going to expand, and we can see we have the bronze. Can expand, and we're going to see the volume we just created for the bronze. And then when I expand the gold, I'm going to see the volume and so on and so forth. That is absolutely cool. Now let's go to the data processing, that is the bronze layer. So for the bronze layer, we're going to use the spark.readstream.format. Now the format is going to be the event hub now because we are reading the data from the event hub that we are sending data from the VS Code in it. So we have the event hub as the format, and the option is going to be the connection configuration dictionary that we specified in the Azure Event Hub connection here, this value connection config. And then we're going to move to the load. So we're going to load, and after loading, we're going to just display the DF. So after reading the stream, we're going to write the stream into a checkpoint. So the checkpoint is going to be the bronze volume. So I'm going to provide the volume path for the bronze as the checkpoint. So I'm going to click on this to expand, and I can see the bronze volume. Now this is the icon for volume in Databricks environment if you don't know. And then I'm going to click on the schema, and then I want to copy the volume path. So I'm going to come inside this placeholder value, carefully Control V. So that's going to be the checkpoint in order to ensure we have fault tolerance and data recovery in case of failure. And then the output is going to be append, and then the format is going to be in form of delta and then to table. So this is going to be written into the weather.bronze data. Now this is going to be the name of the table, the name of the schema, and then the name of the catalog. So we have the three namespace. So I can go on and Control Enter to run the code, and let's see what happens. Okay, so we can say stream initializing. So now I'm just going to wait for some couple of moments, and I'm going to expand this display query one, or let me just expand this one first. Now we're going to see that we have the input versus processing rate, and then we have the records per seconds, and then we have the batch duration in seconds. So we can say data is now coming into our bronze volume of the bronze layer, and then we can see we have this data in form of binary format. Now this is actually difficult to say. So for example, we can say we have the body column, we have the partition, and then we have the offset, we have the sequence number, the enqueued time, the publisher, partition by, properties, and so on and so forth. Now we're going to convert the event sent, which is in binary format, to a tabular format, and that's what we're going to do in the silver layer. So I'm going to scroll down, and as you can see, even before we go on, you can see this is actually growing. So this is actually a real-time data processing. So this is going to be increasing from 13 rows to 14 and so on and so forth. That is cool. So let's go to the silver layer. Now in the silver layer, we want to define the JSON object using the struct type and the struct field. So we're going to call each of the keys. So we have the city, latitude, longitude, and so on and so forth, and then we have the appropriate data types. So I'm going to run this code to define the JSON object, and this executed nicely. And then we want to move to reading the data from the bronze layer. So you can see we are reading from this weather.bronze data table. So this is the read stream, and then we're going to use the width column. So we want to use this body, and then we're going to use the call method to extract the body.cast. We're going to basically cast the JSON object as a string values. So we can see we have this section here. We're using the df.select. So we are selecting this body.city keys, and then we are casting as a string, and then we are also aliasing or alias as a city. So this is going to be the name of the columns in the tabular format. So this is how we can transform the binary format of the JSON data into a tabular format, and I'm going to be displaying the df underscore string, which is exactly this variable we declared here. So after doing that, we're going to also create a write stream. So for the write stream, we have the option. So we want to create another checkpoint, and the checkpoint is going to be to the silver layer. So I'm going to come to in the catalog here. I'm going to expand the silver layer, and then I can see the silver volume. I'm going to click on this, and I want to copy the path. So I'm going to come in here inside the double quote and delete and paste the path. So we can see similar to the bronze, we have the /volumes/weather/silver/silver volume. So this is going to be the checkpoint, and then the output is going to be append, and the format is going to be a delta, and then to table is going to be written to the weather.silver.silver data. So this is going to be the three namespace already again. So I'm going to press Control Enter to run the code, and then let's see what happens, and let's see the transform or the cleansed data in a tabular format. So I'm going to scroll down a little bit, and there we go. So we can see our data is now returned in a tabular columnar format. So we can see we have the city column, the latitude, the longitude, temperature, humidity, wind speed, we have the pressure, precipitation, and so on and so forth to the timestamp. Now I'm going to expand this and I'm going to say also the input and processing rate and so on and so forth, which is absolutely fantastic. Now I'm going to go to the last one, which is the gold layer. So for the gold layer, again, we're going to be using the spark.read stream, and the format is going to be a delta, and then we're going to call the table, which is weather.silver data table, the three namespace applied, and we're going to just perform this aggregation. So we just want to see the average temperature, average humidity, average wind speed, grouped by the city column, and this is going to be a calculation for us. And then we're going to also display the aggregation, and then we're going to also write the data into this checkpoint. So I'm going to carefully come back to this gold expand. I can copy the part of the volume. I'm going to come here, carefully select, delete, and I'm going to paste that volume path. So we're going to see we have this part here, and then for the output, this is going to be complete, okay? Because that's the last layer. And then this is going to be a delta format, and then this is going to be written into the weather catalog, and then the gold schema and the gold data table. So I can go on and execute, control enter to run the gold layer. And let's see what happens. So we can say we have the read stream initializing, and we're going to see our results based average humidity, average wind, temperature, and so on and so forth by city. So we're going to see that in a moment. Let me just expand so we can see the silver layer. So these are the number of the columns, that is the PySpark.sql.dataframe.dataframe. So let's just wait for a moment, and you can see this is going on, and we should see the final results. Amazing. So we can see we have the city grouped by the average temperature, average humidity, average wind speed, and the record count, which is absolutely fantastic. Now I can expand this, and then we can also see all of these dashboard. We can even come here and see the raw data in form of the JSON object. That is cool. Now everything is working fine. Now let's quickly come to this tab, and by the way, you can see we have this icon. This tells you that we have a streaming data going on. So I'm not going to interrupt or terminate this job. So I'm going to come to this tab, and then I want to go to the compute, and I'm sorry, I'm going to go to the catalog, and in the catalog, I'm going to expand the data. Now let's just view the data in the bronze. So I'm going to expand now. We can see we have tables 1, and then we have volumes 1. So these are different things. So I'm going to expand the table, and when I click on this, I can see the overview. So we can see the columns. Now this is the binary format, and let me go to the silver layer. Now in the silver layer table, we're going to see that we have the names of the columns in a columnar method. So you have the city, latitude, and so on and so forth. Now I'm going to click on sample data. When I click on the sample data, I should be able to see at least some of the data, and then we can move on. So there we go. So this is everything is looking absolutely fantastic. Now we can also go to the volume. Now again, so when I go to the volume, we can see the details. So we have the temp path directory, and then we have the commit, and then we have all this metadata and the offset. So when I go to even the gold layer, we have similar things. Let's go to the gold layer. Let's see the table first before we go to the volume. So for the table, so this is our calculation that we generated, and then we can click on the sample data, and then we're going to see that city by average temperature, humidity, and so on and so forth. And then when I go to the volumes, we can come here and we can see all the metadata, which is absolutely fantastic. Now, let's go ahead and create a Power BI report on top of this. Now, to do that is so easy. I'm going to come to the marketplace, and then we have the partner connect, which is now in this environment. And you can see we have the DBT Cloud, Fivetran, Tablet, Desktop, and so on and so forth. And then I'm going to choose the Power BI. Click on that. Now this is going to ask me to choose the compute that I want to connect to. So I can see the connect functionality, and then I'm going to browse and choose the weather streaming compute that we're going to be used for this job. So I'm going to click on download connection file, and then it copies downloaded to my download. So I can click on that to open. So when I click on that, this is going to launch the Power BI desktop. Okay, so the first thing we're going to see is this environment, which allows us to authenticate in order to access the Azure Databricks. Now I'm going to use the Azure Active Directory, which is now known as the Entra ID. So I want to make sure that I click on the sign in. I'm going to pick my account, and then I'm going to click on connect. So this is going to automatically connect to my Databricks cluster, and then I can bring the data into the Power BI for further visualization. So we can see we are we have Index Navigator, we have all of these Cornerstone Analytics, Hive, Metastore, Sales. Now I'm going to click on the weather. And when I click on the weather, I'm going to see all the 3 layers, including the default. So we can see the bronze, gold, silver, and the default. Now, I'm going to use the silver layer in order to create Power BI inside. So I'm going to expand. I can see the table icon. So when I click on this, I'm going to see the preview. Now, this might take up to some maybe 1 minute, depending on the strength of your computer. So I'm just going to wait. And after the data is up and running, I'm going to click on transform data. Now, the reason why I'm going to transform the data is because all the columns in our table are being treated as a string. You can see everything is now treated as a string. So I'm going to actually just perform a little transformation in Power BI to transform the numerical columns as a whole number data type. So I'm going to click on this and I can go to transform data, and this is going to automatically launch the data in the Power BI Power Query, which allows us to apply further transformation. Okay, so the data is now in the Power Query. So we can say we have the string, the text, data types all through. Now I'm going to select the latitude, and then I'm going to scroll to the right, and I'm going to hold on the Shift key, and then I want to select the cloud cover. So I'm going to right click, and I can go to the transform data, and I'm going to choose a whole number data type. So this is going to automatically convert them to a whole number for me, which is absolutely cool for the analysis. So I'm going to just click on close and apply. So this is going to close the Power Query and apply the transformation into the Power BI data model, and we can start building insight around the data that is coming. Now this is a near real-time, dashboard in Power BI we're going to create. So there we go. We have the silver data table, and then we can see at the bottom you have the storage mode, which is the direct query. Now this simply means for every visual that we build in Power BI, the Power BI is going to send the queries to the Databricks, and then the Databricks will release the query back to the Power BI, and then we have the visualization. So I'm going to expand this. And then we can see we have this a categorical field like the city and the weather condition. And let's say I want to see the city by temperature. I'm going to just drag the temperature in here, and this is going to create an implicit measure, no problems. Now I'm going to just, as that's going on, I'm going to copy and paste, just duplicate. And let's say I want to see the weather condition by the wind speed. And I'm just going to wait. Now, this might take a while because the Power BI will have to send the query to Databricks in order to generate the insight. So I'm just going to wait and see. Okay, so we have the result back. So we can see we have the sum of temperature by city. So we can see that Moscow is at the top of the list, followed by Houston, Seattle, Chicago, and so on and so forth. Now I can turn this sum of wind speed by weather condition to, let's say, a donut chart. So you can use whatever visualization you want to use in Power BI, and then we can see we have the weather conditions such as storming, foggy, cloudy, and so on and so forth. Now this is a near real time. Now when I click, or I can see now we have this value 162 for Moscow. Now I can click on refresh. Now when I click on refresh, I'm just going to wait for some couple of moments, and the data will automatically update based on the data coming into the events hubs and then into our Databricks notebook. So I'm just going to wait and let's see what happens. This should change from 162 to something else. Okay, you can see it has changed. So Houston is now at the top of the list. So this is 182, 187. Now, this is how we can build a Power BI report on top of the streaming data from Databricks. So we can see we've gone through all of these steps. We started off by going to the VS Code, by generating data, and then we send the data into the Event Hub that we created, and then we establish connection to the Event Hub, and then we implement or architect the Medallion Architecture. So these are all the code. You can go through it. Now, if you need this the source data that I use, I'm going to put the link of my repo, this repository, into this video so you can watch. And by the way, please subscribe to this channel if you enjoyed this video and then you've learned from it. So thank you for watching. Bye for now.